So this is Unit 7, Goal 1. Unit 7, we're going to be talking about exponential equations and logarithms, and this kind of relate a lot. So today we're going to be looking at exponential functions, solving exponential functions, and we're going to look at also inequalities, and then we're also looking at the equation of an exponential function. So a lot of stuff going on here. And that is because we've done a lot with exponents. So all of our rules stay the same. It's just now looking at using those to solve. So that is today. We use this property of equality quite a bit when we're solving. So notice if b to the x equals b to the y, so notice the b's are the same, then y equals, or x equals y. So if 3 to the x equals 3 to the 5th, then x equals 5. So if my bases are the same, then my powers are equal. So that kind of gives you a clue where we're going to solve, how we're going to solve. So here I have 3 to the x equals 9 to the 4th. And if I can get this 9 to be a base 3, so this is a base, if this is 3, then I can put my exponents equal. Right now they're not equal because my bases are different. So we know that 9 is 3 times 3. So I can rewrite my 9 as 3 squared. 4 is still there, and I have 3 to the x. So that would make, we know power to power means that I multiply, so that's 3 to the 8th. So since my bases are equal, my exponents are equal, so x equals 8. And that's how we're going to solve them. So you're always going to try to get these bases to match. Same thing here. I have a 2 and a 4. So I'm going to rewrite my 4 as 2 to a power. So 2 to the 5x equals 4 is 2 squared. So I'm going to rewrite my 4 as 2 squared to the 2x minus 1. And power to power again, we multiply those. So we have bases are the same now. So 5x equals 2, this 2, times 2x minus 1. And then I'm just solving x like normal, nothing different there. So 5x equals 4x minus 2. Subtract the 4x. X equals negative 2. So I'm going to go ahead and look at the inequalities, and then we're going to come back to these problems on population, which are the equation. I just want to keep with this same setup that we're doing here, kind of the same concept. So inequalities work kind of the same way as equalities, just now we have an inequality. So again, if bases are the same, then x is greater than y. So we keep that inequality there. If bases are the same, then x is less than y because of that inequality. So here, a little bit different. I know I want to get this to 5 to some power because this base is 5. But it's a fraction, so that kind of scares us a little bit. But don't let it remember. So let's look at 625 first and see if that is 5 to a power. So 625, 5 goes in there, 125. 5 goes in there, 25, 5, and 5. So 625 is 5 to the 4th. So let's write that. We're getting closer. We have the base, but we have it as a fraction. Remember, if I move locations, so if I move from the denominator to numerator or numerator to denominator, what that does is it changes the sign of my exponent. So I'm going to move this up, and in order to do that, I need to make it 5 to the negative 4. So same concept, just have to remember our rules for exponents. Most of the time we saw negatives, we moved them down so they weren't negative anymore. But here we're going to go ahead and move those up so that these bases now are the same. So then 3x minus 2x is greater than negative 4. Subtract the 3. Negative 2x is greater than negative 7, and then divide by negative 2. Inequality rules still stay the same. Divide by negative. We need to change the direction of my inequality. That's a decimal. Okay, let's look at one more of that, and then we will go back to those problems that we saw there. So again, we have 243 in a new denominator, so we know we're going to move it up. Let's see if we can write 243 as 3 to a power, and I'm picking 3 because that's the base. So 3 goes in there, 81, 3, 27, 3, 9, 3, 3. So 243 is 3 to the 5th. Still not the same, so I move that 3 to the 5th up by changing the negative to, or the exponent to a negative. Now bases are the same, so 4 minus 3x is greater than negative 5. Subtract 4. Negative 3x is greater than negative 9, and then divide by negative 3. X is less than 3. Alright, so that's our process with solving these. We'll do this a lot throughout that because, again, when we get into logarithms, they're really just exponential equations, functions. So we'll do this quite a bit. So if you have questions on that, make sure you ask. I want to go back to these problems here on population. So when I'm looking at writing an exponential function. So this first problem says in 2000 the population of Phoenix was 1,321,045. By 2007 it was estimated at 1,512,986. Write an exponential function that could be used to model the population of Phoenix. So our exponential equation, just like a linear equation, there's an exponential equation, y equals a b to the x, where a is your y-intercept, or your beginning amount, your initial amount. So when we look at this with finances, this would be like the initial, what you put in. So our initial amount, we have 2 points here. In 2000, it was 1,321,045. And then the other point we have is 7 in 2007, 7 years after 2000, it was 1,512,986. So what we're going to do is we're going to plug these in. This is going to be my A. This is, so we have this, y equals 1,321,045, b to the x. But we know that when 7 years, when x was 7, the y was 1,512,986. We need to find this b so we don't have two variables. So let's plug those in. So when y was 1,512,986, x was 7. We don't know b, but we're going to look for it, so we're going to divide by this. To get b by itself. So I get 1.145 equals b to the 7th. And so we know with radicals, to get rid of a radical, we raised it to the power of the 7th. So to get rid of the power, we're going to just do the opposite and do the 7th root. So the 7th root of 1.145 is 1.02. So my equation would be y equals my y-intercept, 1,321,045, times my b, which we found was 1.02, and then x. So if I want to find the population in the year 2020, I'd put in 20. Alright, that's where we're at. We're going to stop this video so it doesn't get long, but if you have questions on this, make sure you come in. Thank you.